Okay, hello guys, welcome to my channel Let's Learn It. So today we are discussing some of the previous year question from the chapter hydrocarbons, and you can see the trend that per year at least 2 questions are asked from the hydrocarbon chapter. So let's begin with our first question. Now in the first question you would see that it's a 3-degree halide with NaOCH3. Generally if it was a 1-degree or 2-degree halide it would form definitely an ether. But since this is a 3-degree halide, it would form elimination reaction would take place. So just look at the options and see which has the elimination product, and it is the option number A. Now read the second question. The type of the reaction for these are, okay, so you have to see which are elimination, substitution or addition reaction. So you see the first reaction, we can recognize that this is an elimination reaction. Second reaction, the Cl is replaced with OH from KOH, so it is a substitution reaction. Now third one, I2, it forms the product, so it is an addition reaction. And fourth one, it is similar to dialdol reaction, so this is also an addition reaction. So just look at the option E, F, A. Yes, so A is the answer here. Now let's look at the next one. Which of the following reaction produces most stable alkene? Now for most stable alkene, you either see the hyperconjugation or you see the Stainsle's rule. Now according to Stainsle's rule, the most substituted alkene is also the most stable one. So just look at the option which has the most substituted alkene, and you would see the D option, that is 2,3 dichloro 2,3 dimethyl butane is the right answer. Now this is a quite good question, the fourth question. It's quite hard also, not a 2-minute one. Okay, so the IUPAC name and degree of unsaturation of compound X is. So the main thing here is to see which should be given more preference, the bridgehead carbon or the double bond. Well, the answer is surprising, and you would have to the priority is more to the bridgehead carbon. So first we would start our, just don't worry, we will start our naming, which is 1, then this is 2, 3, 4, 5, 6, and this here is 7. Please don't name the alkyl groups substituted here. We do not need to name this. We just need to see it is a cyclic or bicyclic compound. So we do not need, require to name give number to the substituents, as we do not do in general naming. Okay, so just see, we could see that starting from 1, there could be 2 rings formed in which the carbon number 1 is included. So it's a bicyclic compound. Now just look at how to write the configuration inside the bracket. So first we write here bicyclo, and inside the bracket X, Y, Z. Okay, so now what is X? X is the number of carbons in the longest part. So what is the longest part? This is the longest part. And so how many carbons are there except the bridgehead carbon? We have to name them except the bridgehead carbon. The number of carbons are 2. Now why is the number of carbons in shortest part? Here, since both the parts are same, therefore here also the number of carbons are 2. And now what is Z? Z is the number of bridgehead carbon. It is 1. Only 1 bridgehead carbon is present in here. So the answer is 1. Or we have to write Z last, and at the last. We always write the number of bridgehead carbons at last. If you have still confusion, let me tell you one. Okay, so please tell me how many bridgehead carbons are present. So what would Z be in this compound? How would you write after writing bicyclo? See, here are still now here inside the bracket, in the longest part, here is 1 carbon. In this part also there is 1 carbon, and there is no bridgehead carbon here. There is no bridgehead carbon here, so it is 0. This would be the configuration. Okay. So now just rub this out. So now we got that it's a bicyclo 2, 2, 1. Now just see, it is 5, 6 dimethyl bicyclo 2, 2, 1. That's for sure. As 5, 6, we could see here 5, 6. 5, 6 dimethyl. Now how to name them? Well, the longest ring, the number of carbon in the longest ring are the total number of carbon. So 1, 2, 3, 4, 5, 6 and 7, including the bridgehead. So there are 7 carbons including the bridgehead in the ring. So it would be a hept. And if you see the double bond position, it's at 2. So it's a hept 2 ene 3. So therefore, the answer would be C. Okay, so let's move on to the next question. The question is, lindane can be obtained by the reaction of benzene with. So how do we obtain lindane? Well, if you know lindane, it is ganaxene. Ganaxene is when we substitute all the hydrogens of benzene with chlorine. So how we do it? We put benzene with Cl2 in sunlight. That's how we get ganaxene or lindane. What will be the most main product when acetylene reacts with hypochlorous acid? Okay, so acetylene would react with, there's no space, I'll make some space. Okay, so let's start. Okay, so acetylene would react with HOCl, which is hypochlorous acid. So first product would be formed. See, we have not given the number of equivalents, so we should consider it always that there is excess of HOCl. So the first product which would be formed here is OH double bond Cl. Okay, and then again when HOCl would react with this double bond would be broken, and instead we would again get here OH and here Cl. Yes, OH would be substituted just directly below the OH. So we know that on a single carbon, 2 OH groups are not stable. 2 OH groups are just not stable on a single carbon. So this OH and this OH would be transformed into C double bond O, and 2 Cl are of course stable on the carbon. So let's just look the option. What is the answer? So what will be the main product? Trichloroacetylide? No, it was dichloro, not acetaldehyde as chlorine was substituted. It is dichloro. C is the answer. 6. C is the answer. As Cl was substituted here. Then we had the CH, and finally we had the CHO. Okay. So the answer would be C. Now next question. In which of the following compounds the bond length between hybridized carbon atom and other carbon atom is minimum? Butane, propyne, propene, butene. So the bond is minimum when there is a triple bond. Why? Because triple bond has hybridization of sp. Now sp has 50% of s character. Has 50% of s character. Now, since it has 50% of s character, it is more electronegative as it is more closer to the nucleus. So the least bond length would be the one which has the highest of s character. Now we have to just see where is the triple, in which compound we can find the triple bond, and you can see it is in propyne. So propyne would be our answer. Now the treatment of benzene with isobutene in presence of sulfuric acid gives. Okay. So for this you definitely need to draw the diagram. We have to react isobutene with benzene. So let's go now. I just don't need to draw the plus. Now isobutene CH3 twice C double bond C. Now if you see this double bond will go here and this would attack here. So the final product would be CH3. Right. This would be a final product. And now you could see the CCH3 thrice. This is tert butyl and this is benzene. So our final answer will be tert butyl benzene. Okay. So just let me rub it out. Okay. So the answer would be tert butyl benzene. Now let's go to the next question. Which of the following carbon atom is most electronegative? Now as I discussed earlier, the sp hybridized carbon has 50% of s character. So the more the s character means it is more closer to the nucleus, the electrons are more closer to the nucleus. So this carbon would be more electronegative. So answer is A, 9th A. Now the next is the reaction method that does not give an alkane. Okay. So first is catalytic hydrogenation of alkenes. No, this is the basic method we studied for obtaining alkane. Hydrolysis of alkyl magnesium bromide. Now this alkyl magnesium bromide, as we know, is at RMgX. Now this is a base, and when it is hydrolyzed with H plus, it forms a hydrocarbon RH, which is mostly CH4. Therefore, we do get a hydrocarbon after reacting with the RMgX. Now, coal-based electrolysis method. In coal-based electrolysis method, we electrolyze carboxylic acid salt to get alkanes. Now, fourth one is dehydrohalogenation of alkyl halide. Yes, from this we do not get alkanes, actually we get alkynes. Just look at the word dehydrohalogenation and we do it with alcoholic KOH. So this is our answer, D, dehydrogenation of alkyl halides. The most trained next question, the most trained cycloalkane is cyclopropane, cyclobutane, cyclopentane, cyclohexane. Now the answer to this question is easy, and it is cyclopropane. Why? Due to the angle strain. Due to the angle strain, the most trained would be cyclopropane. Now next question, chain isomers of C6H14 will be. Now I want you to learn something, that if there are 5 carbon in an alkane, the number of isomers would be 3, and if there are 6 carbon in an alkane, the number would be 4. No, if there are 6 carbons in an alkane, there would be 5. There would be 5 chain isomers, and this is the one thing which you have no formula for. You just have to remember. If you go till below, you get 9, and till 33 you need to till 33 isomers you need to remember. So 5 carbons, for Bitsat you just need to remember 5 carbons, 3 isomers, and 6 carbon, 5 isomers. So the answer would be B. The thing you have to draw and check for this, as alkane you have to draw. You have no formula for it. Now the next question, which of the following alkenes which react fastest with H2 under catalytic hydrogenation condition? Now for catalytic hydrogenation condition, the mechanism of the reaction is that hydrogen are transferred from the catalyst to the less substituted double bond. Okay, so this has 2 substitution. This is also 2 substitution. This has 3 substitution. So this is 4 substitution. So we have to see among between A and B. Well, we have to see which will react faster under catalytic hydrogenation condition. Now between A and B, A is more stable, so the catalytic hydrogenation condition will also be reacted faster with A. So the answer for 13 is A. Thank you friends. This was all for the Bitsat questions. If you like the video, please subscribe to my channel. Please give me encouragement for making such informative videos. Thank you.